Welcome to More Learn, More Teach, where I attempt to simplify the complex. We're going to start our series on concentration today, starting with the basics of what concentration is. A concentration is what we call a solution made up of a solute and a solvent. The solute is the minor quantity, and that could be something like salt, etc., that is dissolved in some solvent, such as water. A symbol that we can use is a big C inside of brackets, and that can be expressed in two ways. We can have it as the solute mass over the total volume of the solution, or we can just express the concentration as the solute mass divided by the total mass of the solution. They are completely different, but very similar, and they're useful in different ways, in different problems. And we'll get into that later on in our series. So for a concentration that is a mass over a volume, we could express that as milligrams per milliliter, something along those lines, or this concept called molar or molarity. Okay, so the one molar is defined as 1 mole per liter. 1 mole per 1 liter. So what's a mole? A mole is a term that describes a number of things. For example, a dozen describes 12. A gross describes 144. Well, in our case, one Avogadro's number, which we're going to round to 6.02 times 10 to the 23rd, that describes a number of things in a mole. Historically, it's the number of atoms that were in 12 grams of carbon-12. Doesn't matter for this lecture, but maybe that helps you understand some historical context. As we said, concentration can also be the solute mass divided by the total mass. This is how a lot of EPA standards are described. This can be expressed in units of percentage, or maybe parts per million, ppm. You could also have parts per billion. All right, so we'll do an example. Here in this example, we have a 2 molar solution of llamas. We have 1 liter of this solution, and below it, we have a tank with 1 liter of pure water. If we open this valve, all of this solution will fall into this tank. Problem we're trying to solve: what is the new concentration of the new solution that's made? So we open this valve, all of the contents drain down below. This is now empty. This is no longer 1 liter of pure water. We now have 2 liters of the new solution. And we're trying to find out what the concentration is of the solution. So now we can find the new concentration, or concentration final, as the number of moles per volume of solution. Now that we've dropped 1 liter of 2 molar solution into 1 liter of water, I now have 2 liters of total solution. I didn't change the number of moles. I started off with 2 molar, so I had 2 moles in 1 liter. Therefore, I had 2 moles in the 1 liter that I had. Those 2 moles went into the new solution. So I still have 2 moles, but I now have 2 liters Therefore, my new solution is a 1 molar solution. Another way of solving the same problem is to use the conservation of mass. So to find the mass, we use our equation, which is the concentration is equal to the number of moles divided by the volume of the solution. Remember, this is very specific to the solute, right? So the number of moles of a solute. Therefore, using algebra, multiply both sides by the volume of the solution, and we end up with the number of moles of solute is equal to the concentration multiplied by the volume of the solution. Conservation of mass tells us that the mass I start with must equal the mass I end with if it's a closed system. That closed system just means there's no losses in the transition. Therefore, the number of moles that I start with, moles at 0, are equal to the number of moles that I end with, number of moles final. Using this equation we just derived, I can substitute the concentration initial multiplied by the volume of the solution initial must equal to the concentration at the end, or final, multiplied by the volume of the final solution. Plugging in the numbers, we start off with 2 molar, so 2 molar solution. That's what we originally started with, a 2 molar solution. We had 1 liter of that initial solution, so we had 1 liter. That must equal to whatever our final concentration is multiplied by the final volume, which is 2 liters. Dividing both sides by the 2 liters, I have the concentration final is equal to 2 molar times 1 liter divided by 2 liters. The liters cancel out, 2's cancel out, and we end up with a 1 molar solution. Now that we've covered the basics of concentration, we will continue this series with some example problems. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.